Alright guys, welcome back. We have finished most of the code of the server.py file and finally we can set up our threading. Now if you remember, we want to split this program into two tasks. The first thread is going to be waiting and listening for connection from other clients, and when it gets a connection request, it's going to accept that connection and add it to the connections list. The second thread is going to come into action when we want to send some kind of commands to a specific client. So for people who are unfamiliar with threading in Python, I'm going to give you a quick overview of what threading is. When you want to do tasks parallelly or simultaneously, then you have to use the concept of threads. So what you can do is that you can imagine that there is a factory in which a lot of people are working. These people are called workers. Each worker is doing a specific job, but all of the workers are working as a unit simultaneously to create a product. Similarly, in our program, you can think of threads as workers. We have two workers in our program who will have to work simultaneously. The first worker is going to handle connections and the second one is going to send commands. Now let's discuss how we are going to be coding threads into our program. We will be creating three functions. The first function is actually going to create the worker threads. We will use a for loop to create both the threads quickly. Inside the for loop, we will create the threads using the threading.thread function and store it in a variable t. After this, we will set the daemon of the threads as equal to true. What this means is that we are telling the threads to release the memory after the program ends. If we don't set it equal to true, then the threads are going to run in the background and it's going to consume some memory even though the program has ended. After this, we will simply start the thread using the start function. Now, the second function is going to store jobs in queue. If you remember, at the starting, we created a variable called job number and it is storing two elements in a list. We need to copy both of these elements to the queue. We are doing this because threads look for jobs in a queue and not in a list. The list format was only there so you could understand the concept of threads better. The third function, called the work function, will distribute work according to the job number. If the job number in queue is 1, then it's going to make the thread handle connections, and if it's 2, then send commands. So these are the three functions that we will be creating in our code. Now that we are going to write the code, things are going to get so much clearer for you. So let's get started by creating our first function. We are going to call our first function as create workers because workers are just threads that are going to do some work. So let's just define this function, create underscore workers. And let me actually just add a comment also that says create worker threads so that you know what this function is going to do when you get back to this function or whenever you are revisiting this code. Then inside this function, we are going to write a for loop that is going to range till number of threads that we defined at the starting of this program as 2. So if we scroll up, you can see the number of threads is equal to 2. Now why have we defined this as a constant? Let's say you are making an advanced version of server.py file that requires 3 threads or maybe 8 threads instead of 2. Now what you can do is just replace this 2 as 8 and you'll get 8 threads. You won't have to change anything at the bottom of this code where we are actually creating the workers. But for now, let's actually let it remain to 2. So let's scroll down. And now that we are looping through the number of threads, we are going to create a thread. How we are going to do that? We are just going to create a variable of t that is going to store the thread. And inside this, we are going to write threading.thread. And inside this, we are going to put a parameter of target that is going to be equal to work. So what is this line exactly doing? Threading.thread is actually creating the thread, and then inside it, it's saying, hey, you have created the thread, but what kind of work do you want this thread to do? So using this target parameter, we are going to create a function of work that is going to tell this thread what kind of work it's going to do, whether it's going to handle the connection or it's going to send some kind of commands. Now that we have created the thread and stored it in the variable of t, we are going to write t.daemon equal to true. Now, as we discussed, this daemon is important because it tells the program that whenever the program ends, make sure that the thread also ends. If it is equals to false and not equal to true, then the program might end, but the thread is not going to end, and that is just going to consume the memory of a server. And if it is a paid server, then it's going to cost you a lot of money. That is why it's important to set the daemon to equal to true. After this, we are just going to start a server by writing t.start, nothing complex, and this is going to create our workers. So what we did was we created a function of create workers, then we looped through the number of threads. So what this for loop is going to do is going to create thread one by one. So right now we have to create 2 threads, so it's going to iterate through this for loop 2 times. And then using this threading.thread function, we created the thread and we specified what kind of work we wanted this thread to do. This function of work is actually the third function that we are going to create later. After this, we set the daemon equal to true so that the thread ends when the program ends, and then at last we just started the thread. Now that we have created the create_workers function that creates a thread, it's time to create the next function, that is the function that creates the jobs. Now if we scroll up, we can see that we have created a list of job_number, and it has a list that contains 1, 2. Now this is actually a list of jobs, so we want 2 jobs to be done, and that's why this list contains 2 elements, which has the first job and the second job. Now there is also this function of the queue, which we have not used till this video. In this video, what we are going to do is that we are going to store this job number inside this queue. Why did we represent this job number in the list format when we actually had to store it in a queue? We actually represented it in a list format so that you could understand what we are doing with the threads properly. But the threads as a concept don't take jobs from a list. They take jobs from a queue. That is why it's important to store this job number list inside this queue. So that is what we are going to be doing in this function, which we'll call def_create jobs. Now inside this function, we are first going to create a for loop. Let's press enter. For x in job number. Now the job number are 2, that is there are 2 jobs, so this for loop is going to loop 2 times. Now because the job number is 2, the value of x will be 1, and then in the next iteration the value of x will be 2, which is exactly what we want in our queue. So we're just going to type in queue.put, and this is how you put elements inside a queue. And inside this we are just going to write x, and after the 2 iterations of this loop we are just going to join this queue by writing queue.join, and that's pretty much it. And now finally we are going to create our third and last function, so that whenever we are creating a new thread, we can tell it what kind of work do we want it to do. So for that, let's just create a function and call it work. And inside this function, we are going to create an infinite loop, that is while true. And inside this while true, we are first going to get the job number and store it in the value of x. So we are going to create a variable of x, and we are going to get the job number from this queue. So for that, we can just write queue.get. And if the value of the job is 1, then the x value will be 1. But if the job number is 2, then the value of x will be 2. Then using the if condition, we can simply check if the value of x is 1 or not. And if the value of x is 1, that is, we are going to use the first thread, we are going to handle the connections. So handle the connections, we are first going to create a socket. That is going to call the function of create socket. Then we will bind the socket, not bin, actually bind the socket. And then at the last, we are going to accept connections. Now let's say if the value of x is equal to 2, then we are going to use our second thread. That is, we are going to send some kind of commands, and that is going to be initiated by starting our shell, that is the turtle shell. So we are just going to write turtle. Let's see, what was the name? Yeah, the function of the name of the function was start_turtle. So we are just going to do that. And after both of these threads have done this job and the queue is finished, that is all of these jobs are finished, we have to call a function known as task_done. So we'll just write queue.task_done. Now let me add a couple of comments so that you know when you are revisiting this code what is the function of this work function and what is the function of create jobs function. So just above the def work function, I'm just going to write do next job that is in the queue, and is going to handle two threads. The first thread is going to just handle connections, and the second thread is actually going to send commands when it is connected to a specific client. So this is going to be the job of this work function. And I'm not going to add any comments above this create jobs function because it's pretty obvious by its name that it is just creating jobs. And now finally our server.py file is almost done. We just have to call both of these functions, that is create workers and after that create jobs. And guys, finally we have created and completed our server.py file. Now before we end this video, let's actually try out our server.py file on a local computer. So for that, we'll have to change this IP address to our local private IP address. So for that, I'm just going to go to my command prompt and type in ipconfig. And I'm just going to scroll up to my Wi-Fi adapter. And you can see the IP address is 192.168.0.102. So let me change this to that IP. Currently the IP address that was written over here was that of a server that we created in our previous section. So 192.168.0.102. Your IP address will be different. So if you are trying this out with me, you might want to go ahead and check out your IP address. So now that I've written my IP address and our server.py file is ready. So let's just run our server.py file and it says binding the port 9999. Then we go back to our client.py file and run our client. Now that we have run our client, we can go back to our server and it says connection has been established. Now, if we want to see all of the connections that have been established with our server.py file. So for example, right now I'm just implementing one client.py file, but if you want, you can send this client.py file to a lot of your friends and all of you can just try it out. You can like execute this client.py file at the same time. And then you can type in some command like list and it's going to show you the clients that are connected to your server. Right now it's going in infinite loop. So let's check what's the problem. So we'll go back to our server.py file and we'll scroll up to our start turtle and there is the problem. So this line of command of getting input should be actually under the while true statement and that's it. So let's go back to our run and we are going to close all the tabs. So let's close all and then we are going to run our server.py file again and then let's run our client.py file again and let's go back to our server. And it says connection has been established. Now if we type in list and press enter, it will show you the clients that are connected to your server.py file. And this means we have successfully built a multi-client support reverse shell program. Now you can connect to multiple computers using your own server. Now that we have listed it, let's say we want to connect to this first client. So we are going to just type in select 0 and press enter and we'll be able to connect to that client. Now, for example, this instead of this just one client, you were also giving this client.py file to other friends to test it out. It will show you ID of 1, 2, 3 and their IP address and then port numbers. And instead of select 0, you could have done select 1, select 2 and stuff like that. But now that we're inside a computer, we can just type in dir, press enter and you'll be able to see all of the files and do all kind of crazy stuff inside your client's computer. And that client can be a friend or a victim if you're a hacker. Now that we are inside our victim's computer, what if we want to go back to the place where we can select the clients? So for that, we can just type in quit and press enter and we'll go back to our turtle shell and we can type in list again to see a list of clients that are connected to our server. So guys, this is pretty much it for this video. In the next video, we are actually going to upload this server.py file to our server on DigitalOcean. So I'll see you in the next video.